Good morning. I'm Jeff Hammond, Executive Director at IGSHPA. Thank you for joining us for August's Town Hall. We're thrilled to have Terry Proffer as our speaker today. Before I turn it over to Terry, I have just a few announcements just to update everybody and give you all the latest on IGSHPA. So with that, we'll start. And some updates. One of the updates to consider is DOE's GTO, Geothermal Technologies Office. They're looking for subject matter experts to review projects in the areas of design professionals, developers, community voice to get the word out, and workforce and labor development. This is part of the $13 million FOA that was announced in July, and it's based upon community geothermal systems. If you're interested, please send an email to the info@igshpa.org address, and we'll forward that on to the appropriate person at DOE. If your company is applying for this this grant, then do be careful with the conflict of interest, and you may not be eligible. So you can contact us, and we can help you with that as well. But it's an exciting opportunity, and let us know if you're interested. Some of the other news and updates to make you aware of. I've mentioned the members only portal in the past town halls, but if you haven't logged on, I wanted to show you just a couple of screenshots so you can see some of the features that are in this members only section. We continue to add more and more content each week, and if you go to the main website, igshpa.org, you'll find the membership menu. If you mouse over that, you'll see a members login. There you can log into the member portal. If you don't have an account, it will allow you to click on the find password or reset password link, and you'll be able to create an account. Some of the nice features here include a drop-down menu. You can see here that I've circled in red the members only resources choice, but you can choose from any of those drop-down menus and take a look at how your account is set up and so forth. This members only resource is the one that's growing weekly because we continue to add more content to this page. You can see here there's an IGSHPA calculator section. We have a dollars per million BTU calculator here, an antifreeze calculator, and links to geoflows and PPIs calculators. So we continue to build this out. We just added 2 new videos last week, one on residential pump changeouts and one on loop pressurization. If you scroll on down, you'll find a bunch more resources for members. So we continue to build that out, and eventually some of these resources will be moved over to the public page. But for now, most of them are on the member portal. A reminder about our conference coming up in December. We're partnering again with NGWA. It's in Vegas this year, which is NGWA's largest attendance. So we're expecting really good turnout. You'll want to make sure that you take a look at the sponsorship and exhibitors opportunities. These are filling up quickly. We just added a new sponsor last week, as a matter of fact, but you can see there's still some sponsorships available. Same with the booths. If you're going to exhibit at the show, you can see the white spaces down here in the Geothermal Pavilion are open. We'll have a big banner hanging from the ceiling so that everyone will see this Geothermal Pavilion. But the location is just great. This is the entrance right here. You can come in the front entrance, and right at the entrance, you'll see the IGSHPA Pavilion. So if you plan to exhibit, you'll want to reserve your space pretty quickly because they are going fast. Also, a reminder about CEUs and renewals for your certifications. You'll need to submit CEUs to renew that certification. And the town halls and the Dig Deepers are part of those CEUs. You can earn points for each of these town halls and Dig Deepers. Please send a chat message, if you would, that includes your name and your email to IGSHPA. You'll see IGSHPA's logged on to this Zoom conference, and that will count your points for the CEUs attending this town hall. Some housekeeping, if you would, please enter your questions in the chat. And at the end of Terry's presentation, I'll read those questions, and Terry can address any comments or questions at that time. So we will be able to kind of keep things on track that way and not have interruptions. And if you would, please mute your microphone if you're not speaking. By using the chat feature, it does make it a little bit more orderly for that. Finally, I need to read this disclaimer and potential conflict of interest just to make sure that we all know where we are with regard to town hall and dig deeper presentations. The upcoming presentation represents the opinion of the presenter and does not represent any official position, opinion, or endorsement of any products or services by IGSHPA or its members. IGSHPA town halls and dig deeper webinars are for member updates and education on the latest information in the geothermal heat pump industry and are not meant to endorse one technology or brand over another. It is the presenter's responsibility to disclose any conflict of interest or position that may arise in the content of the webinar. So I will stop sharing my screen and turn this over to Terry Proffer. Terry Proffer has been involved in the GSHP industry since 1992 after a career as a petroleum geologist starting in 1979 after graduating with a geology degree in 1978 from Sul Ross State University in Alpine, Texas. He has designed closed loop ground heat exchangers for small residential applications to facilities exceeding 350,000 square feet of conditioned space, including various commercial, institutional, and military projects. Terry is a manager for Major Geothermal of Wheat Ridge, Colorado, a firm specializing in the design of closed-loop ground heat exchangers, thermal conductivity testing, installation quality assurance, functional testing, and GSHP system forensics. So we're thrilled to have Terry this morning. It's all yours, Terry, if you'd like to share your screen.
All right, I appreciate it. And let me make sure I can still do that. Yeah, let's go next. Okay, just some typical abbreviations. Some of them are not very scientific. For example, BF at the very top, bottom feeder, pursuit of cheapest product, service, installation. See also value engineered towards the bottom. And then there's some actual recognized terms such as HE, heat extraction, that sort of thing. So I'll use some of these abbreviations and terms in the presentation. If you forget all of these definitions, just hit the chat for a question and we'll respond. Next, please. So contract administration, what is it? Well, it's really quality assurance to make sure that what is designed goes in as intended. What we've found in the industry, especially as ground source is growing, especially on commercial projects, we have a lot of situations that become problematic that could have been avoided by some on-site quality assurance or contract administration by the person who designed the system to begin with. So a couple of key points. CA, make sure that the design, the basis of design is honored. The industry standards for the construction methods and procedures are adhered to. Quality control procedures are followed to verify system integrity, and that includes things like pressure testing, verifying things have been purged of air, that sort of thing. And the quality of the construction documentation, that is the plans and specs, is really the key for this, and it's also the benchmark for future reference needs should someone need to get in and put in a utility or something over a loop field. Typically the CA should be provided by whoever is the designer of record, whether it's contractor, designer, mechanical engineer, or a designated third party that's going to provide this level of assurance. Next, please. So once field is installed and buried, you're not going to get to it again. CA allows for problems to be resolved quickly during construction to not compete with other projects or other processes and slow them down. And finally, what effective contract administration can do is reduce the number of requests for information, change orders, and delay in construction. Next, please. Just some learning objectives. I'll let you guys just read through those real quickly. And I'll just kind of highlight some things here. It really is part of the design and construction process. It's where design meets construction and make sure that things are what is expected for the installation. Also, CA gets the designer involved with the construction team personally, so direct communications become easier. You know, it's a lot of times people start installing a system, they never know who designed it, and it's, you know, some disembodied entity out there, and you know, that human contact is lost, and accordingly that communication can be a bad, or lack of communication can hurt the project. One of the things that I'm pretty adamant about is doing a pre-construction meeting with all the parties involved to make sure everyone understands things, that we go over the submittals, everyone's on the same page. Next, please. So CA objectives: contractor awareness and comprehension of design details, confirm contractor awareness and comprehension of the performance that we're expecting out of the system, verify design parameters are followed and there's an understanding of that. We really stress integrity testing of the system, and we'll want to also do post-installation tests such as header pair flow balance tie-in and communication with the above ground part of the system. Next, please. So the previous slide, that's the ultimate objective of contract administration. We don't want train wrecks. Next, please. So closed loop heat exchangers, what kind are there? Well, there's surface water heat exchangers, which can be a polyethylene coiled loop field or a stainless steel plate heat exchanger. That's one type of closed loop system. Next, please. A horizontal can be a straight line ground loop or a slinky excavated pit. Next, please. And you can also do a horizontal trench system. Next. And finally, vertical, which is probably the most common, particularly for commercial. Next. We do the occasional, as an industry, horizontally drilled ground loops. They sometimes are the best tool in the toolbox for sites where, for whatever reason, you can't drill a vertical loop, you can't do a big excavated pit system. So it's just another tool in the toolbox to get the job done. Next. And due to the time constraints, we're going to focus on vertical loops, but some of the things we're going to cover apply to other types of closed loop heat exchanger systems. Next. So where does CA start? Starts with the design. As a designer, you need to be aware of what contractor assets can do. You don't want to design a system that can't be done. You've got to honor presiding regulatory requirements. Your drawings and specifications have to be sufficiently detailed that people can understand them and execute them. They're also a benchmark for later quality assurance during the installation. Specifications and worksheets are necessary for good as-built documentation. Drill logs, grout testing, progress testing schedule, etc. These are all go into the job book, and one thing it does for the contractor, if he does all of these things, it also protects him from a liability standpoint for example, if there's a problem later, did you do this? Well, yeah, if you've got documentation, that helps you out. So next, please. So this is just kind of some of the variables that have to be considered during design, and it also flows into your contracted administration. So while things are not in really complex, there's a lot of components that have to come together to do your design and then execute your drawings and specifications for CA later on. Next, please. Pre-construction meeting. That's where everything starts off. This is after you've done the submittal review. You look for over your pipe fittings, warranties, the grout type, verify licensing, certifications, fusion, endorsements, that sort of thing. Go over the type of testing and integrity requirements such as purging, water treatment, that sort of thing. I don't know, Jeff, if you can click on that submittal checklist, if that'll pop up or not. If it doesn't, I'll be more than happy to share that later. But
Yeah,
what I've done, yeah, no,
want to work.
Yeah, we won't worry about it. What it is, I've provide a checklist that reflects for most projects the submittals that we want to see and review, and it goes through everything from components such as pipe and grout to we want to see what kind of performance the purge pump the contractor has to make sure he can purge the system of air after it's completed and whatnot. So it's a little more detailed than most people deal with, but it also, as I've had a lot of contractors tell me later, said, you know, that was a pain in the butt to do, but it really protected us and we got our retainage back sooner. So there was a good reason for that. Let's go forward. So means and, oh, see. Oh, pre-construction meeting, yes. So we review the design, go through the drawings and specs. By this time, we've done the submittal review and everything should be kosher. One of the things we do as well is we confirm contractor responsibilities. A lot of projects I've been on as a third-party peer review is like no one knew who was going to do the purging of the ground loop and who was going to make sure the building wasn't going to contaminate the ground loop with the air later. So we go over those kinds of things. What expectations we have for record keeping. The other thing is, you as a designer may not know everything you think you do. I always encourage the contractor, say, hey, if you guys have got a better way of doing things, let's hear about it. And a lot of times you learn things that you never thought of because of people that have been doing this for a long time and can really improve the job. Sometimes they make a suggestion that it doesn't make sense because it might hurt some part of the job elsewhere, but that's fine. You want that open communication. And finally, you're going to have a lot of Q&A between the construction team and the designer and get everyone on the same page. Next, please. Means and methods. This is what a problem I've had with a lot of engineers and designers that put out systems that are just the specifications and the drawings are so minimal. And when asked, they'll say, well, that's means and methods. Well, I'll give you an example. If you're the designer and you don't know how to design a reducing manifold and cannot calculate the minimum purging rate and pressure drop, how are you going to know if that ground loop header pair is going to be cleaned out of air? So we, as a designer, it's your responsibility to know those things and post that information in your specifications and drawings. The other thing it does, it lets the contractor know that you understand the construction process on these things. So yeah, just don't leave everything to means and methods. Sometimes if you know the contractor, hey, I don't have to be that detailed. This guy's got his act together. Don't have a problem. Or you might have a situation, you know, I've never worked with this guy before. I better make sure I got my I's dotted, my T's crossed. So means and methods, yeah, there's a lot of things you can't cover in drawings and specs, but the key parts you really need to understand it and have it calculated beforehand. Next, please. One of the things I like to do is assign a discrete header pair letter and number for coordination for each borehole. For example, let's say you get a borehole that the driller runs into something he can't complete. So what are you going to do? Well, if you're on the phone with these guys and it's remote and you just say, well, it's a borehole in the middle of the field. Well, which borehole? Well, a discrete number allows that to be, you know, allows that communication to save a lot of time. So I can't believe how many big projects I've seen where there's no nomenclature on these sorts of things. So just a word to the wise, something to keep in mind. Next, please. I usually post a detail sheet to go along with the site plan, and we'll go over these details in the succeeding slides, but it'll, in my designs, it'll be all the way from the design of the ground loop all the way into the mechanical room, where we will have the manifold configuration in detail to include everything like isolation valves and that sort of thing. Next, please. So one of the things I put on is a summary table on both the site plan and the detail sheet. And this is an example of a recent project. In a glance, it gives you a size and scope of the field, pipe sizes and dimensions, what we expect for grout thermal conductivity. We have a little bit of information in addition that's not really for installation, but just for reference. For example, what was the basis of design for entering water temperature for the ground loop? Well, in this case, towards the bottom there, you can see it's 85 degrees to 35 degrees. That was our basis of design for the ground loop field. Next, please. We'll do a header trench detail that's typical for any number of header pairs in any trench. You'll notice we got in there reference to tracer wire, that sort of thing. If we're going to cross a water utility, we may want insulation board between the header pairs and the rest of the fill. It just depends on the project. Next, please. We'll do a penetration detail. I like to use a positive seal, link seal or equivalent. We just don't want critters, moisture, and contamination coming from outside into the mechanical room. Next, please. This is a big deal to me. I talk with a lot of mechanical engineers that design commercial ground loops, and a lot of them do not understand how to design a reducing manifold. And if you don't do that, you could actually triple or quadruple the amount of flow rate and commensurately a higher pressure drop just to clean the air out of the system. So I work these out in detail on all projects and to make sure that we require the least amount of purging effort to clean these systems out. Next, please. We'll do a suggested spacing in the mechanical room for your header pairs. We don't stick to this in in a hard and fast rule, but the objective is to make sure that there's enough room to do service connections later once you bring in all your header piping. Next, please. This will give a schedule of what we expect for the header pairs. I like to see a PT port on each header pair, for example. If valving and all breaks down or whatever, you can always use PT ports to determine pressure and temperature splits on a header pair. Also, like to leave a detail for the purge ports in between the building and ground loop. And if you'll notice, there are isolation valves on each individual header line, along with a circuit setter. The emblem for circuit setter is kind of like the double triangles there in the middle. A lot of people say, oh, we've got circuit setters, we don't need a isolation valve there. Well, circuit setters don't normally close all the way. The other thing is, when you're speccing your circuit setters, you want to make sure that when they're open, they're full flow and not restrictive, because a lot of circuit setters are not designed to open fully. So if you got like 3-inch header pair spec and you want a 3-inch opening for purging, that circuit setter may inhibit your purging efforts. If you also notice on the left side, I've got a demarcation: work by mechanical contractor and work by the geothermal contractor. That may vary depending on who you're working with, but we like to see one point of responsibility at the ground loop installation. And typically we want the loop installer to handle all of the header piping to the inside, especially if he's going to be the one that does the air purging. Next, please. Mechanical piping legend, pretty typical. Next, please. A borehole cross section. You'll also notice we've gone to specifying RFID beacons to supplement tracer wire and locate tape, because we found that over time tracer wire sometimes breaks down for whatever reason, or it gets cut accidentally. The RFID beacons, we typically have those GPSed as well with the discrete serial number on each beacon. It can really help later on when memories fade to locate these things. Next, please. Excuse me. So the other thing is, we like to see materials properly staged during CA. We like to see the borehole surveyed. We like to watch how product is handled, and we want to keep the inside of the pipe clean, of course. We want to make sure grouting is done immediately upon getting to total depth on the borehole and the loop is loaded. We don't want to wait. I see a lot of drillers sometimes. I've actually had this happen where the guys will drill holes and then later, 3 days later, go in or whatever and put in the pipe and then grout, and then they wonder why they've got bridge offs. Really want to watch fusion work. I've got a lot of bad examples, unfortunately, of people not doing their fusion correctly. Routine temperature checks of fusion equipment, and make sure things are kept clean in the field. Next, please. Just an example of observations: proper staging of product, both grout and pipe. Next, please. I had one job in Wyoming on a school, and all of a sudden the pin flags were disappearing for the hole locations. The driller's pet lab was retrieving the pin flag, so we had to resurvey some. So bad dog, no biscuit. Next, please. Especially in urban environments, we like to see either fusion caps or have the pipes fusion crimp to avoid contamination at the job site. I've had on some urban projects, kids get into a field and stuff down a pipe. Why? I don't know why kids do what they do, but they do it anyway. So this gives you a little extra protection. Next, please. Was on a project and I saw a lot of ends of polyethylene pipe laying around. And what I found was it was a new driller. He wasn't getting to total depth, so on every hole, so his guys were just cutting off the pipe and calling it good. Not a good thing. So be observant when you're out doing your CA visits. Next, please. This is one reason we specify pipe that is designed for ground loop installations that'll have 2-foot markings, so we can verify that if we didn't see the ground loop being loaded, we can verify depth of placement of the U-bend by the footage markers. Next, please. Even staging of header piping. On this project, I did not like that the header piping was unsealed. And even though it's just a little bit of dust and whatnot, that stuff tends to accumulate over time. So we're pretty anal about making sure that people keep the inside of even their header piping clean and capped on a project site. It's one of these things that, you know, well, it's just a little bit, but if every pipe has that, it becomes a lot. So there's people need to be a little more, give a little more attention to detail in protecting the product. Next, please. Actual photos of projects where the driller just did not have any sense of keeping things clean. This particular project was very problematic later. It kept bringing back solids into the system and damaging mechanical equipment. So I had lobbied on the project. I wanted a lot of these holes to be re-drilled. They couldn't clean them out. And the driller said, oh, I'll cover all the costs of if there's a problem, because he was sure he could get all the contaminants out. Well, he ended up paying for a lot of pumps. Next, please. And same driller never learned his lesson. Next, please. Bring your infrared gun when fusion is occurring, and keep something handy like an ISCO fusion reference guide. In fact, I like to see the contractor have those in the field, so they're handy. They're ISCO and others give those away for free, so pretty handy stuff. and checking die temperature should be routine, and not just in the morning, but like every other fusion joint, because a lot of times guys will rely on the thermometer gauge on the fusion die, but that's not the temperature of the die, so they need to check that with a temperature crayon or a IR gun or equivalent. Next, please. Caught this one project where a driller was having a hard time getting a socket fusion done. We did not like that angle for the ground loop being tied in, and as it was cut out, we found that it was not a good fusion joint. You could see where there was not full fusion into that side saddle. Next, please. Just more photos of field checking. Photo on the left is butt fusion, and that's a fusion die for butt fusion on the right. Next, please. This was on a project that we had designed for 600-foot bores, and I was a little walking around, and I noticed his trimming line didn't seem to have a lot of trimming line on the reel. In fact, you could see the core of the drum. There just wasn't very much line, so the driller was not actually grouting from bottom up, and so that was not only contrary to spec, it was contrary to state law on this project. So that had to be corrected. Next, please. Some jobs can be quite messy if it's mud rotary. As you can see this from these two photos, it's quite the mess. So management on site was, it got to be a challenge with other trades in the area. Next. So a lot of projects, I always like to ask the driller if they have a mud recycling device to use, either of their own manufacturer, or they have a pre-manufactured device like a Tibbin mud puppy or equivalent, something like that. It's a lot easier to keep a site clean. Next, please. So one of the other things for CA is maintaining some logs of progress of the project, flow and pressure testing, that sort of thing. Next, please. So this is an example of one of my spreadsheets for tracking drilling progress. I like to have the driller fill these out once a week on a large commercial job, so we know where they're at. This helps. Also, what we found is a lot of general contractors like this, because they can look at their scheduling and see if they're on track or not. So this is pretty handy. It also puts the liability on the if the driller says, yeah, I got the U-bend to the design depth, if he's filling that out and we find that later from footage markings on the pipe that's not correct, then we know we have an issue and we need to go back and address that. Next, please. If there's any question of obstructions in the pipe, we will ask for a flow test on the circuit before it's headed up, typically at the minimum purge rate, to make sure we don't have obstruction in the pipe. Next, please. This does get into means and methods a bit, but we recommend to the driller to pre-test your pipe before you load it and after it. That way you log that, because if there's a header pair that won't maintain integrity or whatever later during testing, you can go back to your logs and say, okay, we're probably safe with the circuit pipe, so it's somewhere in our headering. Next, please. Excuse me. Testing of grout thermal conductivity. That's getting to be a big deal, especially if you've got the host geology has good conductivity. You want to take advantage of that and not slow down heat transfer with grout thermal performance that's not reasonable for the loads and the host geology to get the most out of your loop system. So we like to see that grout test pretty frequent on jobs. Frequency can be dependent on the first couple of tests to make sure that the grout is being blended correctly and tested correctly. One of the problems I have with a lot of drillers is they'll take a grout sample and not get it sent in immediately. And on a smaller job, say 20 or 30 holes, that can go pretty quick. So we like to see that, especially on the first borehole, we like that first grout sample to go in immediately and have it tested. Next, please. So I maintain a grout thermal conductivity log on projects. I found that this is very helpful for judging, do we have a problem with the grout? On these bigger projects, grout performance can have a big impact on the performance of that ground loop long term. So we like to keep an eye on this. Next, please. Of course, we like to see the header pairs pressure tested and properly purged. Next. This is just a marker here on the presentation to show you the different minimum purge rates for different pipe sizes and dimensions ratios. You can get this out of the Expo Design Guide, put together your own spreadsheets for that. In fact, it's noted on the slide here how to determine 2 feet per second minimum fluid flow velocity in gallons per minute, right out of the Expo Design Guide. Next, please. This is an example, an extreme example of a misdesigned reducing manifold. The first problem is it got 40 holes on one header pair. This is from an actual job that we did. It was actually construction defect litigation issue. And if you'll notice on the example at the top, I'm not going to go into all the details, but when we calculated the minimum flow rate, the way the 40 circuit header pair had been laid out, needed 473 gallons per minute to purge. At least had they done the proper reducing manifold schedule, that could have been reduced to 362 gallons per minute. So design of your reducing manifold schedule is important. Next, please. This is a purge log. We like to purge in 2 directions on a header pair. And we'd like to know how long they did it and make sure that the returns were free of air coming back when they're done. So you'll notice that on the log there, we've actually calculated the minimum flow rate for purging for each header pair. So a lot of times engineers say, well, that's means and methods. All we need to do is say 2 feet per second. Well, not all drillers understand how to calculate that. And most do, but some don't. The other thing is, if you're the designer, why shouldn't you understand that? So just, it helps on your documentation that things were done correctly. Next, please. And then, of course, pressure testing. If we have to, we'll go to the ASTM test, but typically a simple hydronic test using water. We do expect, from initial pressurization that polyethylene expands a little bit. So if it's not more than 3 or 4%, you're usually pretty good. Next, please. So following the installation of the ground loop, you can take this a step further, tie into mechanical piping in the building, final purging. One of the big problems we have is the mechanical doesn't purge his system out of either air or debris. And guess what? When you put that in communication with the ground loop, and now you have the gift that keeps on giving for a while. We've also had issues where someone wanted the driller just to put in his antifreeze, and then the mechanical put in his version of antifreeze later. They were not on the same page, and we had a conflict chemically. We've had that happen. And then post-installation testing, header pair flow balance if necessary. Next, please. Documentation. We're real big on making sure that we've got good as-builts. We log all testing results. We want all the manufacturer submittals, particularly pipe warranty, that sort of thing. We want to make sure all the permits and legal documentation is retained. And if there's anything else specific to the project that the design team wants. Next, please. This is just a review of some of the key concepts. As a designer, you want to make sure you understand your site limitations, contract capabilities, what the legal requirements are in your jurisdiction for a ground loop installation. Make sure your specifications and drawings are accurate. and they're compatible with what can be done out in the field. It's also going to be your guidelines as for CA during installation with the contracting team. So CA does provide value. Usually you can resolve issues faster with good CA, reduce your change orders, and head off unforeseen costs. And with all of that documentation, you're going to have a lot higher confidence in the integrity of your system when it's all said and done. And what a lot of contractors have found is that, yeah, it's kind of a pain to go through all this testing and logs, but they usually get their retainage back faster. Next, please. And just some sample questions for learning objectives. If this is something you want to consider, what should the designer engineer be aware of during design and specification? Why should the designer engineer be involved during construction? What level of detail is required for drawings and specs? And what's the value of CA to both the contractor and the client? Next, please. And finally, parting shot. Construction sites can be hazardous, so be safe. That's all I got.
All right, thanks so much, Terry. That was a really good discussion, and I think we have some questions coming up. I appreciate you taking the time to put that presentation together.
You bet.
John asked the question, isn't the pressure drop of a circuit setter on a manifold counterproductive and added cost with little or no value?
Yeah, in fact, I don't spec circuit setters unless we've got really unusually different header piping distances. And I have had projects where we put part of the loop field 300 or 400 foot away from other header pairs that are like within 20 feet of the mechanical room. And we have found that we do get different flow rates, with that big a difference. But on the other hand, if we're say within 10 or 15 cent, 10 or 15% of the same header pair distance from the mechanical room to the first borehole in each header pair set, no, I agree. There's no need for a circuit setter at that point.
Okay, thank you, Terry. We still have a few minutes for questions if anyone wants to add to the chat window here. I did have a question about the availability of this PowerPoint presentation. This town hall is being recorded, so we will be posting on IGSHPA's YouTube page in the next couple of days, so you'll be able to rewatch this town hall. David asks a question here: when drilling bores, how many feet per day is typical for the drilling rig?
Wow, that's going to be dependent on the drilling conditions, geology, experience of the driller, his rig, et cetera, et cetera, et cetera. But, we have projects here in the Rockies from New Mexico to Montana, all the way out to California and Utah, et cetera, where a driller might be able to get 2 600-foot ground loops done per day per rig. And yet we've got other areas where even with an experienced driller and high performance drill rigs, they have a hard time getting a 300-foot hole done in one day. So it really, really varies. This is one reason if you're designing these systems, you need to be talking with local assets to determine, what can you do realistically. And in fact, there's some projects that we understand the geology and we know the drilling conditions. We will not design a ground loop, say, below 200 feet, because we know we're just not going to be able to get the drilling any deeper for economically. So it really is up to the designer to be aware of these things.
Great advice, thank you. I noticed one of your contractors in your slides is the Geo Junkie, so that guy must be very dedicated.
Yeah, I tried to use a generic term for some of those slides.
All right. I don't see any more questions in the chat. Do you have any advice in our last couple of minutes, Terry, for those who are attending with regard to contract administration or how they should should look at that?
Yeah, in fact, I'll just use an anecdote. I did a variation of this presentation several years ago at an ASHRAE conference, and we had like 50 some odd engineers in there. And I asked before I started the presentation, how many of you guys design ground loops? Well, almost everyone raised their hand. And I said, how many of you guys go out and do site inspections? I had 3 people raise their hand. I said, well, after you see this in some of these photos of these disasters, you might want to get your butt out there and make sure you understand. And the comment was from a lot of these folks was, well, you know, we're not drillers, we don't understand. And my response back, and I tried to be nice, but I said, you know, if you don't understand the process, you shouldn't be designing the system. And it really, if you're going to design ground loops, whether you're a CGD designer or mechanical engineer, licensed PE, go out and spend some time with a driller and contractors. You'd be surprised what you learn. The other thing I would urge, IGSHPA is in the process of updating training. We're going to actually, hopefully, we're going to develop some training programs that are very much improved over the past. And I would encourage, if you're designing commercial ground loops in particular, that even though you may not be an installer, you still take some of these installer classes that IGSHPA is developing, because it's really going to help you in how you look at designing a system. I can't emphasize how important that is.
Great. Well, thank you very much. It's perfect timing. We're right at 1/2 the hour. Certainly appreciate your time, Terry, and thank you everyone who attended the town hall. You'll see that on the IGSHPA YouTube page by the end of the week. Also check out IGSHPA.org and click on events for future town halls and dig deeper. If you're interested in doing one of these sessions, there's a form at the top of that events page. If you'll fill that out with your abstract and information about the presentation you'd like to do, we can get you on the schedule. We're always looking for new topics, and especially with all the experience we have on this Zoom call, we'd love to have additional presentations. So with that, we'll end the session, and thanks again for your time. Have a great rest of the week. Bye.
Thank you guys. Appreciate it.